Okay, just wanted to go over a few quick properties of exponents. I first want to just start off by talking about kind of the properties just in general and kind of some vocab kind of related to that. So if you actually go to my Schoology site, you should see that there's a properties of exponent sheet. It's also the first page in our notes. So I'm just going to kind of talk about some basic stuff you should kind of be familiar with and then dive into some general examples. All right, so first talking about vocab, right here, as we can see, when we have something like x to the third, we call that entire quantity a power. And then talking about individual things, the number that's being raised to the exponent, so the thing on bottom, is called a base, right? Kind of makes sense, base on bottom. And the little number in the right-hand corner, we call that an exponent. Now, the whole kind of main idea of exponents or kind of exponential growth is this idea of repeated multiplication. So if we have like something like x to the third, it's really x times itself 2 times. If we have, say, I don't know, like y or like, sorry, 3 squared, or sorry, 3 to the third, that's 3 times itself 3 times. So that's kind of the main idea of exponents I want you to kind of rely on when thinking about these. So let's just kind of talk about some properties. So when we have two powers that have the same base, we simply add their exponents. If you want to see an example, here's one right here. As you can see, if we expand them out, there's our x squared and there's our x, we can see that it combines back to x to the third, so it makes sense that we add the exponents. When dealing with a power to a power, you're going to multiply the exponents. The key thing to look here is for the parentheses. When we have a product raised to a power, make sure that it goes to both of the terms. So you can kind of think of that as like distributing this power. If you want to take a look, here's another example. A common mistake people made is they don't forget to distribute the squared to the number in front as well. So that's where that 4 comes from. Next, zero exponent property. Whenever you have 0 as an exponent, it's 1. Just kind of weird to think about. It's not 0. It's not like 2 or something. It's 1. This one is probably the most complicated and or nuanced. It is a negative exponent, and it kind of has the little bit of a phrase, move it and lose it. So when you have a negative exponent, all you're going to do is move it down to the opposite side and lose the negative, right? If it's in the denominator, we're going to move it up to the numerator, and again, lose the negative. Let's talk about quotient. So quotient means dividing. So when you have two things with the same base and you're dividing them, you subtract the exponents. And then right here, the power of a quotient, this is kind of the same idea as power to a power. All you're really going to think of this as is distributing this power of m to both a and b. So now that we've kind of got our properties down, let's dive into some examples. So x squared times x to the third. By the way, if you ever want to like pause the video, try the practice problem yourself, and then kind of hear my explanation afterward, that would be a really good way to kind of practice your skills and making sure that you're learning what's going on. So right here, we have two things with the same base. So what am I going to do with those exponents? I'm going to add them. Kind of contrasting that to the situation right here, we have a power raised to a power. So instead of adding those exponents, I'm actually going to multiply them. The key thing to look for when multiplying is the two parentheses. Power to a power. Let's go here. Here we have a product of a power. So really we're going to think about distributing this power to both the coefficient as well as the variable. So this is going to result in 2 to the 4th, x to the 8th. You can write 2 to the 4th out. 2 to the 3rd is 8, so times 2 more is 16. So this is going to give you 16 x to the 8th. You can use your calculator if you don't know the powers of 2 off the top of your head. You could also just leave it in exponential form like that. All right, so let's kind of throw in some negatives right here. As we can see, this is very similar to the previous problem, but instead we have this negative sign right here. So here's kind of the main idea. We're still going to raise each of these to the power. But when we raise -2 to the 4th power, and when we raise x squared to the 4th power, -2 to the 4th is positive 16. X squared to the power 4, again, just like in the previous problem, we're going to multiply our exponent powers. So this gives us 16x to the 8th. Same process, but notice how this exponent is even. Let's see what happens when we have to consider an odd exponent. So when we distribute this 3 here, just like how we did in the previous problem, we get -2 to the 3rd, and then x squared raised to the power of 3. -2 to the power of 3 is actually -8. And this is still going to be x to the 6th right over here. The reason why is because whenever you have an odd power for your exponent, the negative stays. However, when you have an even exponent, you're raising that to a negative number, it actually becomes positive. So you can always use your calculator to kind of check to see if that's true, so just keep that in mind. Let's step up the difficulty, not a lot, but just a little. So right here we have a quotient, and I also noticed that we have things with the same base. So since we're dividing and we have things with the same base, I'm going to subtract the exponents. If you can skip this kind of intermediate step right here and just go right to x to the 3rd, that would be fine with me. Whoops, I accidentally messed up my numbers. This should be a 4, and this should be a 3. So let's do this here. So notice how the middle part is still the same here, but then we're raising that to a power. So just kind of talking about order of operations here, we're going to want to deal with the stuff on the inside first, then probably deal with that power. But on the contrary, you could also start by distributing this 2 to both of these. That would be fine as well. I just like to clean up the stuff on the inside before dealing with stuff on the outside. So again, we're going to subtract the exponents to get x to the 4th, and we're raising that to the 2nd power. Now we have a power to the power, so I'm going to multiply those exponents. So that's x to the 8th. Let's kind of consider a larger fraction here. So kind of there's 2 parts. First is this fraction out in front. Next are these variables with x right here. And finally are our variables with y's right here. So here's my first suggestion. Always deal with negative exponents first. Like, you don't have to, but it normally makes your life easier. So I'm going to take this -4 and I'm going to swing it down to the bottom. I'm going to move it and lose it. So this is still 24 over 8. You can simplify that fraction, by the way, by factoring out a 3. So that really becomes 3 over 1. I divided both the numerator and the denominator by 8. That's how I got that, by the way. X to the 3rd and x to the 5th, if I subtract those exponents, I get x to the -2. And then in the denominator, I get y to the 4th times y squared. Since the denominator both has like bases, I can add those exponents, and that becomes y to the 6th. I'm also going to move it and lose it for my negative exponent, so I'm going to bring that down to the denominator and lose the negative sign. And that's my final answer. You know you're done when you can't simplify any more fractions, and all your powers of x and y are neatly contained within their own powers. All right, let's take a look at this one. Again, we're kind of dealing with some stuff on the inside and then some stuff on the outside. So I'm going to clean up the inside first before dealing with this outside function right here. So this is still going to be 2 over 3 because I can't simplify that fraction. There's no other x's, so that's still an x squared in the numerator. And then I have my move it and lose it rule with my negative exponents. So I'm going to bring the y to the third up to the in the numerator, and I'm going to bring the y to the first in the denominator. And this is still raised to the negative 2 power. All right, carrying on my steps, I see I can focus in on those y's right there, and I can actually subtract the exponents because they have the same base. So this is 2x squared y to the second over 3. And we're raising that to the negative 2 power. So here's my trick for when you have a power to a power and that exponent is negative. Instead of distributing a negative 2, I think it's easier just to flip the entire fraction. That kind of deals with the negative, and then you're going to raise everything to the 2, or to the second power. So I'm going to distribute that 2 to each of the terms inside, which gives me 3 squared over 2 squared times x to the fourth and y to the fourth. We're multiplying the exponents because it's a power to a power. 3 squared is 9, 2 squared is 4, x to the fourth remains, and y to the fourth remains. And that is about the simplest I can go, so I know my work is done. So that's about all for my little exponents review. If you want some more practice problems, I would highly suggest going back and just kind of reviewing some of the practice problems we have assigned for homework. So have a wonderful day.